This video is going to look at how to conduct a hypothesis test. So in class we've already seen how to state the null and alternative hypothesis. So if you ever look at a bag of Reese's Pieces, they have three colors, orange, yellow, and green. But are there actually a third of every single color in Reese's Pieces? Now, the first test we could do, we're only going to focus on one color, which is orange. So I want to see if there is a third of orange in every single bag. And you can see here, I have a sample of some actual Reese's Pieces drawn for you. Okay, so first, my null hypothesis, my HO, P is going to equal 33%, or 0.33. Now remember, when you do the null, you want to make sure that you're using the population parameter. Since P are proportions, I'm using P. My alternative, well, when I look at Reese's, it seems to be that they have a lot more than 33% orange. Orange seems to be overrepresented. So I'm going to think that it's greater than. What does P represent? It represents the percent of orange Reese's. So if I were to go ahead and count all the Reese's in my sample that's drawn there, there are 66 Reese's. Of those 66, 31 is orange. So therefore, there is about a 47% of my sample is going to be orange. To me, that does seem to be fairly off from a third or 33%. But how likely is that actual number? So in order to see that, we're going to look at a sampling distribution. So, okay, this website will simulate drawing different samples of Reese's Pieces. So let's assume that what they said is correct. In other words, that we actually have 33% of orange Reese's. So I'm going to tell them the probability of orange is 33%. The picture I had on the previous page had 66 Reese's. So I'm going to tell it that I'm taking samples of 66. I want a very large sampling distribution. So I'm going to tell this website to sample 500 sets of 66 Reese's Pieces. So when I click on draw, it's going to create for me a sampling distribution. Okay, and as you can see down below, here's my sampling distribution. Now, ideally, since the probability of orange is supposed to be 33%, this distribution should be centered around 33%, which it is. You can see it's peaked around 33%. In fact, this actually does look like it could be a fairly normal distribution, but we'll do that in class. Now, if you remember my alternative was that the P was greater than 33. I got a proportion of 47%. I would definitely say 47% is over 33. But how likely is that number? Well, let's look at my dot plot. You can see right here is 45, so 47 will be right to the right of that. And if you look at that, I did just accidentally circle one of them, but there are only 2 dots of those. 2 out of my 500 trials was 47% or more. Now, why did I pick more? Because my alternative, I said, was greater than. When we're doing hypothesis testing, we're never going to just test one value. In fact, we're going to test multiple. Since only 2 out of the 500 trials, or a 0.004 or less than 1% of my samples were 47% or higher, it's probably very unlikely that the percent of orange Reese's Pieces is actually 33%. The 0.004, or the number less than 1%, is the probability of me obtaining my value, the 47% or more, assuming that Reese's really does only have a third of orange. The chance of me obtaining 40% is so unlikely, it happens less than 1% of the time, that more than likely I can reject the null hypothesis and Reese's does not have a third of orange Reese's. So here's just a definition to help you with this. What we're actually looking at, that 2 out of 500, is something known as a p-value. A p-value is the probability, assuming HO is true, we obtain our statistic or more extreme in the directions of HA. What does that mean? Our p-value that we obtained was 0.004. That's tiny. It's less than 1%. So if there really was only a third of orange Reese's Pieces in all samples, then we should only get our sample less than 1% of the time, since we got it pretty sure the null is wrong and that there really is more than 33% of orange in a bag. The smaller that P is, the more likely HO is false. So our sample statistic could not just happen by pure variation.